The circuit for this video is very simple. It consists of a voltage source, a resistor, and a capacitor. The primary purpose of this video will be to demonstrate an AC sweep and a transient analysis using LTspice. First, we need to construct the circuit. Open LTspice. Go to File and New Schematic. If the background is blank, go to View and select View Grid. The first part to place is a voltage source. A simple way to access a voltage source is to press V. Place the voltage source in the schematic and press Escape. To do an AC analysis on the circuit, we need to set up the voltage source as an AC source. To do this, right-click on the voltage source. In the dialog box, click Advanced. On the middle of the right side of the box, under Small Signal AC Analysis, enter an AC amplitude of 1 and an AC phase of 0. I choose an AC amplitude of 1 volt for AC sources because the simulator will automatically assume an amplitude of 1 volt when doing calculations, such as the decibel gain. That means if I were to put in an amplitude of 10 millivolts, for example, the decibel gain of the output would start at minus 40 decibels, since 10 millivolts is 2 orders of magnitude lower than 1 volt. Entering the phase angle of 0 degrees is not strictly necessary, as it will be assumed by the program. I just know there are some of you out there that really need to enter that 0 for the sake of sanity. Once the voltage source is set up, we'll then place the resistor. Press R to place a resistor. Use Ctrl R to rotate the resistor to a horizontal orientation. Without pressing Escape, the placement mode can be changed to placing capacitors by pressing C. A ground can be placed by pressing G. We can switch directly to wiring mode by pressing W. Remember that wiring is started by clicking on a part terminal. The direction of the wire can be made to change by clicking at the point where we want the wire to corner. A wire ends when we click on the terminal of the device we want to connect to. When wiring is complete, press Escape to end the wiring mode. Only the voltage source is set up at this point. If we right-click on the resistor, we can enter a resistance of 1 kilo ohm by typing 1K. We can also edit component values by right-clicking on the value in the schematic. If we right-click on the C next to the capacitor, we get a dialog box that allows us to change the capacitance to 10 nanofarads by typing 10N. An AC sweep will give us the frequency response of the circuit, that is, the output of the circuit relative to the input of the circuit over a range of frequencies. Go to the Simulate menu item and select Configure Analysis. Select the AC Analysis tab. The default output of the AC sweep is a Bode plot. To perform an AC sweep from 10 Hz to 1 MHz with 10 points per decade, that means per factor of 10 in frequency, we will set the type of sweep to decade. The number of points per decade to 10, this will be enough to create a smooth plot in this case. The start frequency to 10 Hz and the end frequency to 10 MHz. SPICE is not case sensitive, so a capital M would be interpreted as 10 milli by the program. To get megahertz, we have to type MEG. Run the simulation by clicking on the green run arrow in the toolbar. To see the output, click on the node between the resistor and the capacitor after the blank graph appears. The decibel magnitude of the voltage and the phase angle of the capacitor voltage appear on the graph. Any aspect of the graph can be edited by right-clicking on the element we want to change. If we want the traces to be thicker, we can right-click in the graph area and select waveform settings. I will modify the data trace width to 5 and click OK. If we want to change from a decibel scale to a voltage scale, we can right-click on the vertical axis and switch from decibel to linear. If we want a linear frequency scale, we can right-click on the horizontal axis and uncheck the box by logarithmic. A transient response is the same type of graph you would see on an oscilloscope. We can use the same circuit, making some minor changes in order to see how to do a transient analysis. We start by changing the source. Instead of a generalized AC source, use a sinusoidal source. To do this, go back to the schematic and right-click on the voltage source. Under Function, select Sine. From the handout, the source is to have an amplitude of 10 volts at 16 kHz. Enter 10 in the amplitude box and 16K in the frequency box. Click OK. To set up the transient analysis, under the Simulate menu, select Configure Analysis. Select the Transient tab. Since our source is operating at 16 kHz, and I would like to see a couple of cycles, I'm going to set the stop time to 125 microseconds. The period of a 16 kHz signal is 62.5 microseconds. Type 125U. To obtain a smooth plot, the maximum time step should be significantly smaller than the stop time. A value of about 1/100th of the simulation interval should be sufficient, so I will enter 1.25 microseconds. For this simulation, I will leave the time to start saving data blank. This feature is useful when there are large capacitors that need to be charged and there is a drift in the steady state output of the voltage. Click OK and place the .trans statement in the schematic. The .ac statement will automatically be rendered inactive. Click on the green run arrow in the toolbar. To display the voltage waveforms, click on the nodes on either side of the resistor. The green wave is the input voltage waveform and the blue wave is the voltage of the capacitor. We have come to the end of the handout, and this concludes the basic introduction to the most common tools that we will use in LTspice. Thanks for watching. Have a great day.